Okay, hello guys. Let's check. We'll start a new stream today. So the plan is to continue our, let's say, grind. We want to solve as many problems from LeetCode as possible. So let's see how far we'll get. So this will be session number 11. We'll check the microphone. Let me see. Is everything good? Okay, so let's try a little bit closer. I'll move a little bit closer to the microphone. Maybe like that will be better. Okay, I think we are good. So let's start then. Okay, I'll put a phone here. So probably people will join a little bit later, but we'll see. Okay. So yeah, last time we stopped. I forgot so shuffle array somewhere here, I think. But we see some reshuffle on LeetCode's problem. Let's say easy problems. So they removed a couple, they added a couple new probably. So let's check this one and see what's with this one, design parking system. So designing a parking system. Okay, so it's quite a big one, a big explanation. So let's try to understand what exactly it's requested from us. Design a parking system. Designing a parking system for a parking lot. The parking lot has three kinds of parking spaces: big, medium, and small, with a fixed number of slots for each size. Parking system int big, int medium, and int small initializes objects of parking system class. The number of slots for each parking space are given as part of the constructor add car type. Checks whether there is a parking space for car type for the car that wants to get into the parking lot. Car type can be of three kinds: big, medium, or small, which are represented by 1, 2, and 3 respectively. A car can only park in a parking space of its car type. If there is no space available, return false, else park the car in that size space and return true. Okay. So we have our parking system. So we'll need to design it. So I guess from us, it's requested to create this sort of application. So we have an interface. So the interface, we have this struct. So we'll need to add more details to this struct in order for the application to work fine. Okay. So I assume, yeah, it's not like a real application. So I assume this will work on a basis of an instance. So we'll have this one instance of parking system. So yeah, bool add car type. One thing which for me it's a little bit not clear is add car boolean. So once again, let's see, what do they want from us? Yeah, okay, so first we'll need to store the configuration. So as we can see here, they want us to create this parking system. So usually this means we'll need to return a self, and the simplest way possible will be like to have a big, medium, and small. So that's the first stage. So we'll be creating our struct. This is what we'll be returning, but before that, we'll need to add those properties in our system here. So we'll have like a big, which will be an i32, medium, which will be an i32, and a small one, which will be an i32 as well. So we added the properties, and then we created our parking system. Checks whether there is a parking space of car type for the car that wants to get into parking lot. Car type, a car can only park if parking space with its car type. If there is no space available, return false. Else park the car in that space and return true. Yeah, that's the trouble, because we kind of cannot do that here, because I was expecting here to have like a mutable self, because we cannot park the car and return true in that case if we pass a reference. So this is a little bit like a poor design on their side. It's a little bit poor design, but I guess we'll adjust mutable and everything will be fine. So this is pretty straightforward. What we'll need to check first, if we can do a match car type. So we'll have free option if it's like 1. Then we'll do we'll see if there is space for that car type. If 1, what's 1? A big, 2 will be small, medium, and 3 small. If car type if self.big minus 1 will be greater than 0. This means do we have space for our car to be parked? So this is a way to how we can write it. If there is space, then we'll do self.big will be equal, or we can do this structure, which will tell that we want to remove from big one property. And then we will return like true. So we should add the same like code for the other. So 2 and 3. So it will be like 2, and this will be like for 3. So 3 will be small, and this will be medium. And I guess that should be it. But yeah, I guess we'll need to return false in all the other cases. But I don't really like this code. I mean, it should work. So yeah, let's give it a shot and see if this works or not. I expect it should work, but we will refactor it, because this is very ugly. Yeah, let's try to run it and see what. Oh, it's exhaustive. Yeah, unfortunately it's not, but it wants us to cover all the cases. So Rust will make sure that we need to cover invalid car type. So we'll need to write something like this for the case of i32s. Null, false, false. What? Okay, so let's see what's the big deal. So big. So we start big. Yeah, probably we should tell equal here all those signs. Because yeah, we need to have one more. It's not like okay, this works. Though I hate the structure, so we need a way on how we can write this code a little bit better. And the simplest way to do it, we will return the car type or cars. Let's put it this. We'll return cars, and we'll not need to write all this code in this form. So one will be like self.big. Two will be like self.medium. Three will be like self.small. So we'll be returning cars, and then we'll write this logic. If cars minus 1 is greater or equal than 0, then we'll do like cars minus 1, and we'll have true returning. Else we'll return false. So it's a little bit different structure. Yeah, we'll need a comma here. It's a little bit different structure. Yeah, and we need to correct all the errors. But I want it to be a reference. And not only reference, but I want it to be a mutable reference. Something like that. Because I want to edit cars. It will not allow me to do it, because we'll need to do it like this. But it should work in the end. We'll need to remove the reference. Okay, so what's the trouble? Minus can be used in I32 if you difference the left hand side, cars minus 1. Okay. But if we dereference it, will it work? I don't know. Okay, it did work. Yeah, let's submit and see what's the deal with this one. Okay, it's accepted. Looks like it's pretty slow. And I don't get why it's so slow. So let's see. Fits. If no fits. Okay. But it's too muches. I don't like the too muches. I mean, overall, it's the same solution. What I did here, I just get the reference of the car, and then I return the result. So probably it's just some random stuff. I do not see why this algorithm it's much faster than mine. Yeah, so that's our first implementation. As you can see, if 1, we check this, return -1, true, false, but we refactor it. So we refactor it, and now it's a little bit cleaner. Okay, good. We solved this one, so it's accepted. Let's move to the next one. Find words containing character. Yeah, let's see what's up with this one. You are given a zero indexed array of strings words and a character x. Return an array of indices representing the words that contain the character x. Note that the returned array may be in any order. So, okay. LeetCode code. Output 0, 1. E occurs in both words. E and code as we return indices 0 and 1. 0, 2. Okay, this is a pretty straightforward problem. So we can write it in one go. We have the words. So pretty much what we'll need to do, we can try to write it in a functional way. So yeah, let's try to iterate them. So we'll use an iterator. Then we'll need to enumerate them. We'll need to enumerate because what's expected from us, it's returning the indices. Then we'll need to filter. So we'll have like our word, and we do like word contains x to string. So we will be filtering all the words containing x plus string, but we need to make sure that we have our indices. So indices will be the first one, word containing, and then we will map. As well, we'll have only indices. We don't care the word now. We'll return only indices, and we'll collect in the end, because what's expected from us is to return a vec of i32. So that's it. That should do the trick. Let's see if this compiles first. What's the trouble? Okay, closure. Oh, so they want us to add a reference. Okay, so let's add the reference. Ah, yeah, that's correct. We'll need to cast it as i32 as well. Yeah, so this compiles and looks like the tests are accepted. Let's try to submit. Yeah. So not the fastest solution, but let's see the other solution, what they are about. Yeah, pretty much exactly the same, but we don't need to do that. Why did I try to do it like this? Let me see. Yeah, this works. So let's resubmit it. Yeah, so this is a little bit faster because we don't do the casting to string. But yeah, it's exactly the same solution. So yeah, we do iteration, enumerate, map. So pretty much exactly the code. So that's randomness, 0 ms, and we got 2 ms. So this is random stuff. Cool, this is one as well accepted. Let's move on. Timeout cancellation, next one. Yeah, this is JavaScript. We don't do JavaScript here. We try to stick on Rust, so let's ignore this one for now. Yeah, let me refresh the page. Array wrapper. Let's check this one. Array wrapper as well, JavaScript. And no, I don't want to solve JavaScript today. I use JavaScript at work, and probably we'll have like another day where we'll be solving like easy problems in LeetCode, but in JavaScript, but not today. So array wrapper, divisible and non-divisible sums difference. Yeah, let's check this one. Yeah, Rust, awesome. Divisible and non-divisible sums difference. You are given positive integers n and m. Define two integers num1 and num2 as follows. Num1, the sum of all integers in the range 1n that are not divisible by m. Num2, the sum of all integers in the range 1n that are divisible by m. Return the integer num1 and num2. Yeah, this is an interesting one, but as well pretty straightforward. So I guess in order to solve this one, we'll need to know the concept of how to create a range in Rust, and it's pretty much easy to do that. But what we'll need to do is to have wait, sum of all. Okay, so num1 will be sum of integers range 1n that are not divisible by m, and num2 1n. Okay, so in order to solve that, we'll need to create like two variables. So let's create two mutable variables, so like num1. We can start at 0 because this will be a sum, and the second one will be num2. We can write a comment here, divisible by m, sum divisible by m, sum not divisible by m. For reference, for us to, yeah, actually it's vice versa. Not divisible and divisible. Now we'll need to capture and have these ranges. So what can exactly we do? So we create a range in Rust. We start using this code. So this will be creating a range. So it's pretty straightforward. This means create a range, something like 1, 2, 3, 4, 5 till n. And with this range, we'll have like, let's call it item. We don't need this parenthesis, so let's remove them. Now we do if item is divisible by m, so that's the term called modulo or modulo. And this means it's if, for example, a number is divisible by 2, we'll have like a number modulo 2 should be equal 0. This means that this number is divisible by 2. So if it's divisible, then we'll increment num2 item. Else, we'll increment num1 item. And finally, we'll need to write like the result, which will be a num1 minus num2. So let's check briefly if the types are good. Yeah, it's i32, i32, so we'll not have troubles. But anyway, let's run the code and see if this compiles and works. Yeah, this works as expected. We see all cases are good. Let's submit this problem. Awesome. So yeah, so let's check the other solution, which is pretty much the same approach, but actually it's a little bit more expensive, because I do this in one go, but this solution creates like two filters. So n+1, yeah, I don't really like to use n+1. There is this syntaxes you use from 1 to equal n. Okay, so just a moment. Okay, so I see some other people joining. So yeah, we solved this one as well. Let's move on. Let's solve another one. What will be the next one? Yeah, smallest even multiple. Yeah, let's check this one. Yeah, these are very easy problems. So they are specifically intended for let's say super beginners, and I'm trying in these streams to show a case on how to solve them. Maybe some people have trouble starting solving problems in LeetCode. So I'll try to show the approach on how you can solve it. So yeah, first I guess the approach is to read the problem, what in itself is requested from us. So smallest even multiple. Given a positive integer n, return the smallest positive integer that is a multiple of both 2 and n. Yeah, let's see an example. So for example 5, it's 10. The smallest multiple of both 5 and 2 is 10. So let's see 6. The smallest multiple of both 6 and 2 is 6. Know that a number is a multiple of itself. Yeah, okay. So, I mean, what will be the formula? So if it's an odd number, then we'll multiply by 2. Will this work? If it's an odd number, we'll multiply by 2. Okay, so smallest even multiple. So for 7, it will be 14, I assume. For 8 will be 8. For 9, 18. Yeah, I guess that will be the logic. So if we'll check if it's odd or even. So if n modulo 2 equals 0, this means it's even. Then we'll return the number itself. Else we do n multiplied by 2. And that should be it. Another way to write the same code will be using a match expression. So if we have 0, we'll do it like we'll return n. Is it though? Let me think. Yeah. And for the other cases, it will be n by 2. So that should be it. So using a match expression, maybe it's a little bit faster. So let's try to run this code. Let's see, does it work? For our test cases, it does. Let's check the other cases. Yeah, this is what's expected from us. Cool, solved another one. So yeah, this kind of problems, yeah, we'll sweep through them pretty fast, but sooner or later we'll start to get like more difficult and more interesting problems. At least for me, more interesting. Yeah, let me give it a refresh and see what else. Okay, so we stopped here. Let's solve this one. Yeah, again, let's check what's expected from us. Number of employees who met the target. There are n employees in a company numbered from 0 to n minus 1. Each employee I has worked for hours I in the company. The company requires each employee to work for at least target hours. You're given a zero index array of non-negative integers hours of length n and a non-negative integer target. Return the integer denoting the number of employees who work at least target hours. Yeah, this is another one-liner. And in order to solve this problem, we have the collection of hours and the target. So we need to apply a filtering function. We need to apply a filtering function which will denote that how many employees worked at least target amount of hours. The code which we'll need to write for that will be something on those lines. So hours, we'll create an iterator, then we'll use a filter function. I guess hours will be h, let's call it h for now. If h is greater or equal than target, this means at least the same amount. We'll be filtering all those users, and in the end we need to count them. But a count function will return a new size, but we need to return back an i32. So we'll need to cast it as an i32. So that should be it. Let's try to run this code and see if we're good. Okay. H. Yeah, probably we'll need to consume it. Probably we need to consume it, and then we should be good. That's a little bit weird because if I consume hours, I'm expecting to have an i32 here, but not a reference. But anyway, I mean, we can always dereference and check the value. So probably this interface is not really correct. So actually what we are given here is something on those lines. Yeah, let's check if that's the case. Actually not. Okay, okay, so weird. Yeah, let's submit it and move on. Anyway. Yeah, we solved another one. Pretty easy as well. Let's move to this one. Find total time spent by each employee. Okay, so that's MySQL. We'll skip for now. Goal pass interpretation. Yeah, let's check this one. Is it Rust? Yeah, it's Rust. Awesome. Okay, so what's the thing here? You own a goal parser that can interpret a string command. The command consists of an alphabet of G, brackets, and or brackets all in some order. The goal parser will interpret G as the string G, as the string all, and all as the string all. The interpreted strings are then concatenated in the original order. Given the string command, return the goal parser interpretation of command. Okay, so yeah, kind of understood. So this is a classical replace function. So we have our string command, and we'll need to replace something. In our case, G will replace with G. So if we need to replace G with G, in this case, we pretty much don't need to do anything. So what we'll actually need to do, it's to replace this with the O and this with al, and that should be it. So let's create a string, but this needs to be mutable, I guess. Or no, response, let's call it response, and we'll do the following, like command replace, in our case we'll replace this with O. Can we chain that? I never tried to chain in Rust. I know for sure in JavaScript it will work, but in Rust I didn't try it. Yeah, let's try to run it and see what we'll get. Yeah, it did work. Okay, so chaining works as well. Probably we don't need to use like in this form, let response. This is a good pattern when you write like application codes, because often you need to debug stuff. And if you do things like one-liners, which let's say looks better, but you'll have troubles always to debug it. So usually a good practice, it's like to store it into a variable and then return this one, because then you'll put a breakpoint here at line 5, and you'll be able to stop here and check the response or the resolution. But for LeetCode, we don't care about debugging. Anyway, we cannot do here debugging. So we will just have this as a one-liner. Let's submit it. Yeah, it works. Let's check the other solution. Oh my God, it's a little bit more complex. But the good thing, it does it in one go. So probably that's why. It got a good result. But I will never go this way. I mean, yeah, probably it's a little bit faster, but both of those algorithms are O of n or linear. I do not see any reason to complicate this algorithm as much to make it only in one swipe, not two. Because when we do replace once, it will do it like one go. And actually, I'm not sure. I need to see the complexity of replace function in Rust. So probably it's a good, like, let's check complexity of replace function in Rust of string replace. Yeah, let's check this. Yeah, let me zoom it for you guys as well. Okay, so we have string from replace. So let's find the replace. Where is the replace? Okay, so we have replace. Replaces all matches of a pattern with another string. Replace creates a new string and copies the data from the string slice into it. While doing so, it attempts to find matches of a pattern. If it finds any, it replaces them with the replacement string slice. Yeah, it doesn't write how it does it, but we kind of implemented something close to similar in last time to find the first index of a needle in a haystack, and that algorithm has a worst case scenario of n square. So probably something similar here. Yeah. Okay, so yeah, these two algorithms are not the same. So this will have like, it will be like n square. I assume it's written in the form of n square. But this solution, it's O of n, so it's much faster. It's a much faster interpretation. So maybe the guy who wrote this, yeah, spent a little bit of time to write it. But it depends. I mean, I personally sometimes will even if the algorithm looks a little bit worse, still I'll keep it because it's clear. So it's easy to maintain. So we have like a maintainability factor as well. But anyway, okay, so we have this. Let's resubmit it. And let's move on. We solve this one. That count pairs whose sum is less than target. Yeah, let's check this one. Given a zero-indexed integer array nums of length n and an integer target, return the number of pairs ij where 0 equal I is smaller than j, and n, and nums I plus num j is less than target. Okay. Okay, so we have 3 pairs. So target is 2. So 0 and 1, since 0 is less than 1 and nums of 0 and plus nums 1, it's 0 less than target. 0 and 2, which will be minus 1 plus 2, which will be 1 less than target. And 0 and 4. Yeah, I guess here we do not have any other option to write something smarter than 2 for loops and making this complexity of the algorithm being an n square. Whoa, can we do it? Actually, can we do it? Can we think of a better algorithm? Something better than big O of n square. Yeah, let's check the hints. Maybe there are some hints, but Yeah, the constraints are small enough for a brute force solution to pass. Yeah, actually, with this hint, they tell that 2 for loops, it's a good solution. So yeah, let's let's write this 2 for loops. What can we do then? So for I in 0 nums len. For j, we cannot compare themselves, so j will start at 1. Yeah, but in this case we can do even better. So we'll do like 2 minus 1, and here till the end. We do if I is smaller than j and nums I plus nums j is less than target. What should we do with them? To count them, I guess. Yeah, return the number of pairs ij. So we need to count them. So yeah, we'll have like a count starting at 0. We'll increment our count here. And we'll need to make sure we return this count. Yep. So this will be a kind of a brute force solution. We do pairs. We check this one with this one, 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 and we got our results. Yeah, that would be a way on how we can do it. Maybe if we do a sorting algorithm, if we sort the numbers, we can get a faster one. But I don't know. I mean, not sure if we need to spend more time here. So let's check first if this compiles. Yeah, it does compile, and we've got good results. So let's submit it and see if this this works. Yeah, this works, and we are lucky. We got 0 ms of runtime this time. Yeah, let's check another solution. As you can see, it's exactly the same algorithm, but still I've got lucky this time. I've got 0 ms, but it's the same. Yeah, solved another one. Let's move on. Yeah, so we have a pretty good pace today, like literally swiping through all these problems. Sorry, I have a sore throat. Oh, that's MySQL. Let's ignore this one for now. Yeah. Array wrapper, we know this one. It's MySQL. This we solved. Range sum of BST. I think that this one we solved last time or something. Because I go straight forward. I mean, really, I'm going straight forward. Everything which is Rust, everything is solved till this moment. Number of unique subjects thought by each teacher. Yeah, very likely this is a MySQL. Let's check, but how it's structured, it's MySQL. Okay, so ignore. Running sum of 1D array. Running sum of 1D array. Okay, so I guess we have a little bit of a more interesting problem. Yeah, let's check. Given an array nums, we define a running sum of an array as running sum I equals sum of nums of 0 till nums I. Return the running sum of nums. So for first will be sum of first. For second will be first to second. For third will be till third, and the last one will be sum of everything. Let me think. Let me visualize and imagine this algorithm. Probably it's time to get to our drawing board, or is it? Let me think. So first we'll include first element. For second we'll include everything till the second. For third we'll include everything till the third, and for fourth we'll include everything till the fourth element. Okay, I guess here what will be the complexity of this algorithm? We will need to run a for loop for each element, and at worst case, for the last step, we'll have another for loop for all elements together. So I guess worst case scenario, not worst case, but it's some sort of n multiplied by n by 2, something like that, I guess. But n by 2, it's still considered as n square. So complexity of the algorithm will be something as well on notation of big O of n multiplied by n by 2. But is it n by 2? Yeah, we should count it specifically, but it doesn't really matter. In either case, it will be a big O of n square. What does it mean? It means we have like 2 for loops. But let's check the hints. Think about how we can calculate the nth number in the running sum from nth number. Oh, but here it's a trick actually, because we have the sum from previous ones. So we don't actually need to recalculate it every time. Yeah, that's a good point. So sometimes it's useful to know the hint, because at every stage we have a running sum. We know the previous. So let's see, for example, this. Let's check this one. So let's assume we started with sum 0. If we're at the first stage, it will be like 0 to 1, and we'll just compute this one, and we'll write here 1. And then we'll write everything till this stage multiplied by 2. Yeah, for this one we'll need the drawing board. Okay, so let's follow the example above. So we have like 1, we have like 2, we have like 3, we have like 4. Initially I thought we kind of will use some for loops and every time to compute them. So we will do for the I0, let's say I0, we'll start from 0 to 1. From I1, yeah, let's put it here, I0. From I1, we start from 0 to 2. From I2, 0 through 3. From I4, 0 to 4. But this doesn't make any sense. Why should we do it? Because we can have a smarter algorithm. We can store the sum. So we can have something like this. So we'll have like let sum. And let's assume we start with 0. At iteration 0, and this will probably a better name here will be to use like prev sum, a previous sum, or previously calculated sum. We start with 0, and once we got to this element, the previous sum will be 0. We sum them together, and we'll write down the result. Then we'll store the resulting sum, in our case, in our prev sum. And once we got to the next element, we will just sum the previous sum with the element, and here will be like 3, because we have 1 plus 2, this element, and it's equal to 3. Once we got to here, it will be like 6, and once we got to here, it will be like 4, to be like 10. The question is, do we really need to store it? Probably yes. Probably we need to store it. The other way is to look every time in the resulting array at the last element to keep it. But this will make the algorithm a little bit more complex than needed. So yeah, let's code this. I like this. It's linear. So we transformed initially. We thought it to be like a big O of n square, which is a pretty bad algorithm. We make it in big O of n. So let mutable prev sum, let's call it like this, which will be 0 at first. Then we'll go all items. So for item in nums, we'll need the result, a resulting vector. So let's create another one. Let mutable result, which will be a vec. And now we'll do simply like that. Result sum will be equal prev sum plus item. We'll push this result sum, and most importantly, what we'll need to do is to make prev sum to be equal to the new resulting sum. And that's it. Yeah, and we need to return the result. So that should do it. Yeah, let's check this stuff. Yeah, this works. Let's submit. Yeah, let's check another solution. Yeah, as you can see, oh, that's mine. But yeah, so scan. I think I never used scan. What does it do? Probably it just operates on the item. So scan, I use fold. Yeah, not sure. Not sure. So as we can see here, it returns some option. Yeah, it's weird. I don't know this structure. Maybe in the future we'll get to use it one day. Yeah, about memory, we are not the fastest because we use a bunch of variables. We use like this prev sum. Probably we should ignore it, but then I guess the algorithm will not be as fast. But okay, good enough for now. Yeah, let's refresh the page. Are we done with the first page? Yeah, this is my SQL as we know. How many numbers are smaller than the current number? So let's check this one. Yeah, I want to finish with these easy problems. I want to get to some more complex ones. Given the array nums, for each nums I, find out how many numbers in the array are smaller than it. That is for each nums I. nums j is less than num I. Return the answer in an array. Okay. For 8, we'll have 4. Okay, so intuitively, I think for this one, we'll need to sort it. Because if we sort it, we can find the position of the new element, and this will imply how many elements actually are smaller than this one. But I'm thinking, what should we do with the? Yeah, let's check. Okay. Yeah, this one is a little bit more tricky. I feel like it's simple. But still tricky. So yeah, let's try to visualize it. Yo, Enough. Hi, Enough. Hello, hello. Yeah, I may see your comments with delay, guys. So uh, if you write something in the chat, please make sure to wait a couple of minutes. What language is that? Hi, hi. Okay. So this is a Rust language. It's very popular. It's a kind of a low-level language, pretty popular among the geeks. So it's called Rust. You can find more details about it on rustlang.org, I think, or .com. I forgot, but that's their website. So I try to learn it and use bunch of and a way to learn a new language is through solving problems. Oh yeah. Okay. So concerning, so there are different types of languages. So Python, it's a scripting language. You cannot compare like Rust with Python. It's order of magnitude of difference. So Python is a higher level language. So Rust, it's more like low level language. Or let's put it this way: Rust, it's a compiled language which produces a binary code or assembly code, let's call it this way. But Rust is an interpreted language. So when you write some code, there is an interpreter which will parse it, and it's slower usually. And also it has a garbage collector, so it's less efficient. Comparing Rust with Python, Python is way orders of magnitude worse than Rust. But Python has its own useful benefits. It's pretty clear syntax, very popular, has a lot of a huge community, mainly in American universities. It's used by PhDs, doctors, different scholars. So it's different. If you want to write, let's say, more efficient code, you'll start writing Rust, but at the same time, at the entry level, it's way more difficult. So with Python, you'll move much faster. With Rust, you'll spend a lot of time understanding how to write code. It has its own like tricks with lifetimes, with memory allocations and stuff. Yeah. So, Einav, where are you from? I'd like to know my viewers. Okay, so uh, once Einav will answer, let me try to go with this problem. I'm trying to figure it out, an efficient algorithm, but nothing comes to my mind yet. So let's go iteratively. I started doing LeetCode problems about a week ago. I use Python because it's the language I'm most proficient with. Do you have any tips? Yeah, Israel. Oh, uh, yeah, pretty sad things happens with Israel this year. So my condolences. Hope everything is like a little bit more peaceful now in your country. But about tips, first and most important tip, if you just started coding, is to choose the right problems. Because sometimes in LeetCode, an easy problem you will spend like hours to solve it, and even if you are a seasoned engineer. So I think a better way to start for beginners will be to sort. So you change difficulty. So you choose easy. You start with super easy stuff. And then try to sort with the highest acceptance criteria. So this will be a filter for you. Um, the problems will be pretty easy, but at the same time, you'll learn little by little the syntaxes of the language. You learn small tricks, so you'll advance. At least you'll have some, let's say, a linear growth period. Because if you go with let's say problems from 1 to x, you may stumble upon a problem which is marked as easy, but it's very difficult, and you'll lose motivation to continue. Or probably you can alternate. So if you want to have like a better run, you may go with let's say, sorting with this acceptance in descending order. So highest number, this means super easy problem, like close to everyone solved them. But if you want something more difficult, you try to get like with low acceptance. So those problem means that they were not uh, uh, so easy, and not a lot of people finish them. So for these streams, I personally I started with some, let's say, difficult problems, and I spent a lot of time on them. I now want to fastly go through these easy problems and get to more interesting, more difficult problems. Yeah, I'll be back in a minute. I just need a glass of water. About languages, I don't know. I mean, in Rust, it's pretty difficult to operate with linked lists, navigation of trees. So yeah, probably in some languages it's a little bit easier, but that's the trick. That's the way on how you learn the language itself. So so yeah, we spent quite a lot of time in one of my previous streams. I think we spent close to an hour to try to figure it out, how to create from a vector a linked list. And we were close, and I cheated a little bit. I used the Copilot AI to hint us the solution. And we were very close to the right solution, but we couldn't figure it out by ourselves. So Copilot helped us. Okay. Yeah, so about our problem, let's see what smart things we can do to solve it. So take screenshot. I just need a small screenshot. I need these values. If there are problems I don't manage to finish, should I look at the answer or leave it for when I understand more? For sure, yeah. If there is a problem, you don't know how to code it, you try at least to solve it. I mean, try your best. Try to do search on Google. Try it. I mean, spend some time. But after a while, I mean, after half an hour or an hour, if you see that you cannot have a solution, you just look at the solution and try to understand how those person arrived there. So you try first, but then look at the solution. Even after you write your code and it works, I suggest to look at the solutions, because sometimes you learn some stuff, some new stuff. Maybe a useful trick, maybe a way on how you can write it more efficiently or with less code. Okay, so let's use a new canvas and let's try to see what can we do with this one. So our goal, assuming we have 8 here, what we need to do is to count how many numbers are less than 8. So my initial thought was something like this. We will sort this array. So if we're sorting it, it will be like 1. It's a little bit too big, I think. Yeah, we don't need it to be that big. So 1, 2, then 2 again. Then it will be like 3 and 8. So assuming we sorted it, we will go number by number. So we'll do 8. We'll try to find it in the sorted array, and we found it at this position. So this will be like position 5, and this means we'll have like 5 minus 1, which will be 4 other numbers. But this, what number problem is that? I'll try to solve it too. Oh, okay. So that's 1365. How many numbers are smaller than the current number? One, 3, 6, 5. Okay. So we sorted it. We have this 8. But what happens with 2? Because if we find 2, then we know that only 1 is bigger. We found it at this position. But actually, do we care? We found 1 position 0. We found 2 at position 1. Okay. We found 3 at position what's the position here? So 0, 1, 2, 3. So 3, it's at position 3. So for 3, we expect to have like 3. Yeah, this works. Okay, so this works. So the algorithm in our case will be something on those lines. So first thing, we will sort it. So first stage, we'll sort sort numbers, but we need to copy them. We need to, let's say stage 0 we'll copy, because we need to know this, the order. We'll sort it, but one thing which I don't really like is to do an every time to search it again, because we'll have n square algorithm, but we want to make it n log n. Because we'll have like n log n, because we sort it, so it will be something like this. Sorting will be n log n. I mean, depends on the implementation, but let's say a quick sort, a decent quick sort implemented will have like a worst case scenario will be n square, but like a medium or average will be an n log n. And then we'll need to find the index. Find index. And finding the index, it will be like O of n. But we'll need to call this find index for every number. So n times find index. And our algorithm will become like n square. So in order to avoid this, we can store the finding indexes in a hash table. So we sort it, and then we'll have like, assuming we found item 1, we'll store it at position 0. We found item 2, and we mark it position 1. We'll have item 2 again at position 2, but as it's already in our hash map, we'll not need to add it back. We'll keep only the first item. For item 3, we'll have at position 3, and for item 8, position 4. And actually, this will be our results. So once we'll need to create our vector, we can look from the initial source. So initial vector, in our case, it's 8, 1, 2, 2, 3. So we have 8, subsequent value will be 4. We have 1 here, which will be 0. We have 2, the value will be 1. We have 2 again, the value will be 1. And we have the last one, which is a 3, and the value for 3 is the index 3. So in this manner, we'll manage to optimize our algorithm. Instead of becoming an n square, we will keep it still at n log n, so a little bit faster. But the trade-off in this case, will use way more memory. So it's a faster algorithm, but more expensive on the memory, because we'll need to make this dictionary. I assume most of the people just sorted and then did this and find for each item, find the index and show the value. Okay, so we got an algorithm. Let's try to code it. Okay, so smaller than current. So first thing which we'll do, we'll need to sorted nums, which will be like nums. We'll need to clone it. Yeah, I mean, this sort and stable, it's faster. So I see a lot of Leetcodians, they use it. For production, probably I would not advise it, but if you want to have like a very optimized solution. Maybe this makes sense. Yeah, now we need to create our dictionary. So for that, we'll need our hash map. So use std collections hash map, and here we'll have like a dictionary. I call it dictionary. Now we'll go with sorted nums iterator. We'll go one by one, but actually we can consume it. So we can use int iterator. We'll call a fold function. Yeah, probably, yeah, let's use fold here. We'll pass our hash map as a first argument to the fold function. Then we'll have a mutable accumulator. So we'll accumulate the values and then move on. And then we have our value, or let's call it value here. So let's write the code for that. Yeah, I don't really like how this is formatted. Probably I do it like this. And like this. Yeah, this looks a little bit better. Okay, so we have our item, and then we'll need to check if it exists or not. Fastest way, I guess it will be like entry and then value, or insert value, or oh, sorry, kind of what we did, we kind of need to store, most important for us, it's to store the indexes. So we need to enumerate, and then here it will be a little bit more complex because we'll have like index and value. So we'll have value or insert. Yeah, let's write it the long way. So if accumulator has value, doesn't have value, yeah, let's write it like this. Then accumulator insert value index. If it has, we don't care. So yeah, that's simple enough and should work. So we have now our dictionary. And then what we'll need to do is to create our response vector. Okay, so yeah, probably I'll create it here at this stage. Yeah, let mutable result. And we'll need to iterate again through nums. Iterator, and then we'll wait, what do we want to do? Yeah, actually we can write it a little bit smarter. So we can do a map item, and then we'll do like dictionary get item. We'll call a flatten, and we'll collect the values. Yeah, this code, it's a little bit more cryptic. Maybe for new persons will be not clear. But first, let's see if this compiles. Because if this compiles, I assume this should work pretty nicely. But if it doesn't, contains, I think it's in JavaScript. Why? That's weird. Let me check a thing or two. Where do I have a hash map? Yeah, here I have a hash map. So contains key. No, I just need to has. I'm pretty sure has new. Yeah, let me see like this. Yeah, probably not this one. Assign cookies wherever we sold this one. This let's try to use here. Drain get hash map has. Okay, wherever. We'll use get. Get it, so works for us. Match accumulator dot get value. So sum. We will do nothing. For none, we'll do accumulator insert. For value, we have the following index. Okay, that should be it. Let's try like that. What's the trouble now? Oh, so yeah, value needs to be a reference. And here, wait, action insert. Yes, like that. No, I don't want this. Guess like this. Oh, you want me to put here a comma? Yeah. Okay, so can build over the elements of type uSize. Oh yeah, so index is uSize, so we need to cast it as I32. And we need to dereference them. Yeah, that's why Rust. Oh. This cannot be dereferenced. Okay. That's interesting. And how should we do it in that case? Maybe I can apply a mapper function. I don't know. So we'll have references here. So if you do a map, but then we can do maybe a flat map of x and something like this, because this will be like I32s. Option of I cannot be dereferenced. Okay, so let's do flatten then, and we will get rid of options, and then we'll do a map. But I'm thinking, why do we need to do it like this? Maybe we'll do not here. So we cannot, yeah, okay, anyway, it works. It works for now. It's a little bit more ugly than initially intended. Guys in the chat, if ever anyone understands or wants more explanation on what this code does, because it's not like trivial as the previous ones. So this, I feel like it's a little bit more complex problem. At least I have something to tell about it. Do I need to explain line by line what this stuff does? Is anyone interested in that? Because if not, I'll move on. I'll move on to the next problem. Yeah, let's try to submit it first and see if it covers all cases. And it does. Yeah. So these guys, instead of a hash map, uses a temporary vector, which also works. But I feel like it's overall the same. It's overall the same approach. Yeah, this is this guy, and this will be yeah. I have no clue why this is considered a simple problem, an easy problem. It's not like straightforward at all. So you'll need to know a little bit of data structures. But funny thing, a lot of people solved it. So maybe we are on LeetCode. There are only geeks and stuff. So that's quite interesting. Okay. Yeah. So yeah, we used a lot of memory as expected, but we have a pretty fast algorithm. So third in our case. Yeah, let's move on. So accepted. Yeah, it's accepted. Let's move on to the next one. Daily leads and partners. Yeah, that's MySQL. We'll ignore it. Maximum number of words found in most words found in found. Okay, let's see this. A sentence is a list of words that are separated by a single space with no leading or trailing spaces. You are given an array of strings sentences where each sentence I represents a single sentence. Okay. Return the maximum number of words that appear in a single sentence. So I guess they request us to count how many words are in each sentence, and then get the biggest. Okay, so this is a pretty straightforward one to write. It's a one-liner. Yeah, but we'll write it in a little bit more lines. So we'll use Rust iterators as always. And the way to write this code will be something on those lines. So sentences. We will have like iterator. For each sentence, we'll apply a mapper function, which will receive the sentence. Then inside this mapper function, okay, so here we will count how many words are, and how we'll do that. So we will split sentence that split white spaces. I think that's the name. Yeah, this is a little bit ugly because I need to double check it in my editor. So let's assume I have a string test to string, because I have a autocomplete here, split white space. Okay, so it's just split white space, call the function. So we'll have it split white space. This will return an iterator, and then we will apply a count function. Will tell us how many words are in this sentence. This mapper function, then the next stage, will probably, I don't know if that's what. Okay, so yeah, we'll need to find the max. So yeah, actually this is everything which we'll need to do. So how many lines we have here? Yeah, like 3 lines, but it's a one-liner, and if we remove the comment, yeah, let's run it and see if this works. So first we need to make sure it compiles. Okay. Expected I32 found option of view size 532. Yeah, and kind of will need to unwrap it. Yeah, it doesn't want it to be like that. Okay, let's try this. Will it work like that? Yeah, we'll need to provide expected I32 found view size. Okay, so we'll need to cast it as I32. Yeah, okay, so this compiled. Again, we use iterator, we map through all sentences, we split everything by spaces and count how many. Yeah, maybe in order to not pass it here, we can do it like here. It's overall the same code, I think. No changes. Yeah, maybe like that will be a little bit cleaner. Yeah, let's submit and see if this compiles and works. Yeah, as well, solved pretty fast. Let's see other solutions. So for each matches, oh, this is a smart one. What this guy does, it goes through each for each sentence and counts how many spaces there are, and add one more, because you have like if there are 2 words, you'll have only 1 space, so you'll need to have like +1. And it also has like a maximum where it counts, it compares the maximum. So let's see why this is better than what we do. Yeah, I don't know, maybe this is just random, because I don't feel like it's still in one go. Still in one go. Let's see how much memory this stuff uses. It doesn't show. So probably this is just random stuff. like 0 to ms. It's close to random stuff. Yeah, this one is as well accepted. How many did you solve today? Let's see. I think close to 10 or 11. Yeah, exactly 10. So I think we're good for now. Exactly 10 problems. I guess for today we're good. Probably next stream will be on Friday. I'll try to have another like grinding session. We'll continue with the solving problem. So wish everyone a great day. Yeah, have a nice day, guys.